Welcome to this series on computer networks. And the purpose of this series is to provide you with the kind of information that you need so that you feel competent in terms of diagnosing and resolving issues that might pop up on computer networks. So the first thing that we need to address is, what is a computer network? In other words, we need to come up with a working definition. And for our intents and purposes, a network is a group of electronic devices that we are going to connect together in some shape or form so that we can facilitate the kind of communication between them and the kind of sharing of resources between them that we want. Now, there are a few benefits of this, and I'll just highlight three, and this list is by no means exhaustive. So what are the three benefits that we are going to look at? One, networks allow us to transmit and receive data. And when we say data, we're talking about images. So you can think about Instagram, for example. We're talking about text. So you can think about emails, or you can think about WhatsApp. We're talking about audio. You can think about Spotify, or you can think about WhatsApp as well. And you can share video. We're talking about like a YouTube. We're also talking about WhatsApp once more. So that's the benefit. We can transmit data and we can receive data. So that's one benefit. Another benefit is that we can share resources. And the resources can be hardware resources, like a printer, for example. So we have an office, and we have several persons within the office who are sharing a single printer. But it can also be digital assets that we are sharing, for example, files. So those assets that we spoke about earlier, like images and audio and video and so on, those can also be shared. Additionally, we can share applications, which are programs that are going to carry out particular functionality. So we can share applications as well. So the second benefit here is that we can share resources. And the third benefit is that we can save time and we can also save cost. So in terms of sending data, we can save time, because when we send it over the network, it is transmitted, let's say, instantaneously. So there's very little delay between the time that it is sent and the time that it is received. If we compare this with traditional methods that used to exist, such as the post office, then we can see the amount of saving in terms of time that we are achieving. Because when we send the email, it is sent instantaneously. But if we were to post a letter, it might not reach until 2 weeks, 3 weeks down the line. So we're able to save time. The other thing that we are able to save is cost. So going back to that example about the printer, it is going to be very costly to put a printer on every desk within an office. If we assume that the office has 10 persons, then that would mean we'd have to buy 10 printers. The challenge with this is that the printers are not going to be used 24/7. So when I put a printer on everybody's desk, it is not as if they are going to be using that printer continuously throughout the day. So it would therefore be better if I could buy one printer and find a way to share it among these 10 individuals. And the good thing is that a computer network facilitates this kind of sharing. And in so doing, we can cut down on cost, because instead of having to buy 10 printers, we can now buy one printer and share it. So we have looked at what a network is, and we have looked at a few benefits which are offered by the networks. It is now time, therefore, to dive into the architecture of a network and see how things operate. And on the screen, we have an example of a network. This is a simple network. And for all intents and purposes, we can call it a peer-to-peer network. we have two PCs or two computers, and we have labeled them for convenience. So we have PC1 and we also have PC2. These computers are connected via some wire, as denoted by this dotted line that you are looking at here. Above the machines, you will realize that there's I'm going to call it a number, 192.168.10.1 for PC1 and 192.168.10.2 for PC2. These numbers are going to be unique for each device that is on the network. And these numbers, these unique configuration of numbers, is known as an IP address. And this is the first thing that I want you to bear in mind. Every device that is going to be able to communicate on the network, that is able to transmit and receive data on the network, needs to have an IP address. And as mentioned before, that IP address has to be unique within the network. We'll talk about this a little bit later in a deeper way or a more fulsome way. The other thing that you'll find below the computers is that there's another number there that kind of looks strange. This number is expressed in hexadecimal format. By the way, there are some knowledge that you need to bring into this series. For example, binary. You need to be comfortable with binary information and how to convert from binary to octal and how to convert from binary to hexadecimal and vice versa. Because that information is going to be critical in terms of understanding some of the things that we are going to discuss. Suffice it to say that we have a hexadecimal number below each computer, and this hexadecimal number is also unique. And this is called the MAC address. Once again, we are going to dive a bit deeper into what MAC addresses are, where they are found, and what is their purpose or significance in terms of the network. So we have a basic network, two computers, they are connected via a wire. And we now want to see if they can communicate with each other. Now, the tool that we are using in this case is Cisco Packet Tracer, which is a simulator. And I encourage you to download it for yourself, to register it, and to make use of it in terms of duplicating these networks that we are going to be using as demonstration. And we are using these demonstrations because it will provide you with a better understanding of what is happening to the network and within the network. So the challenge now is, how do I determine whether or not PC1 is able to communicate with PC2? And I'm going to go to I'm going to go to PC1. I'm going to open up the configuration tools, and I'm going to go to the desktop utility. And on the desktop utility, I'm going to make use of the command prompt. Remember, this is a simulation, and it's simulating pretty much based on the Windows platform. So whatever we are doing here, you can do something similar on your machine once you load a command prompt. And that is assuming that you are making use of a Windows box. If it is that you are making use of a Linux box or a Mac, for example, then there's also some feature there that will allow you to open a command prompt and to execute similar commands. So it won't be the same. The names might be different, but what you get when you execute these comparable commands is going to be the same kind of information. I'm going to click on the command prompt, and in Windows, there's a command called ping. And the purpose of ping is to allow us to try and communicate with another device that is on the network. So I am on PC1. If you look at the top here, you realize I am on PC1. And PC1 has an IP address of 192.168.10.1. But I want to communicate with PC2. And PC2 has an IP address of 192.168.10.2. So that's what I'm going to put in the command window. So I want to ping this machine, 192.168.10.2. And I'm going to ping it by making reference to its IP address. I'm going to hit enter. And you're seeing that it is sending over some data. It says 32 bytes of data. And we are getting a response from PC2, which is 192.168.10.2. And then it gives us some statistics at the end. We sent 4 packets. This term packet is going to become important as we dive deeper into the content. But suffice it to say that 4 packets were sent and 4 packets were received, which is good. It means that we lost none of the data, so the loss is equal to 0. And this tells us that we are able to communicate effectively with PC2. Or to rephrase, PC1 is able to communicate effectively with PC2. We can also do it from the reverse. Can PC2 communicate with PC1? So once again, we are going to click, go to the desktop, open the command prompt, and this time we are going to ping PC1. Remember, we need to know the IP address of the device that we are going to communicate with. And in this case, it is 192.168.10.1. So we are on PC2, and we want to communicate with PC1. We hit enter. Once again, 32 bytes of data has been sent. And we realize that we're now getting a response from PC1, which is 192.168.10.1. 4 packets were sent. 4 packets were received. We have a 0% loss. So all the data was sent properly. So we have these IP addresses that were configured onto these machines. And by the way, these were configured manually, which means I am the person who put them on. How did I put them on? Well, if we go to config, you will realize that there's something here that talks about fast Ethernet. Click on it, and you will realize that in this section that says IPv4, which means IP version 4, I have placed the IP address there. So that's 192.168.10.2 because we are on PC2. So if I wanted to change this, for example, I could change it to .10. And if I exit the screen and I go back in and go back to the fast Ethernet, then you realize that it now says 10.10 at the end. I want it to be 2, so let me change it back to 2. And we're going to ensure that that is safe. Now you might be wondering, why am I using fast Ethernet? Well, whenever we are using wired connections, and in this case, I have a wired connection, then the most prevalent protocol that is being used is the Ethernet standard. So those cables that you plug in the back of your machine, they all operate on the Ethernet protocol. So that's why we are setting up the IP addresses on the fast Ethernet interface. Once again, this term interface we will talk about it more in depth as we dive deeper into the course. So our aim right at this stage is just to show that we can create a network. We can have the computers or the devices communicate over the network. And we are also illustrating or highlighting the point that the concept of an IP address is very, very important. And this IP address in most instances, has to be configured. So it's either going to be configured by you manually, or you're going to set it up so that it can be configured automatically by the network. And that will take us into this protocol above here that talks about DHCP. We'll talk about that a bit later in depth. So another thing that I want to illustrate here is that we can find out information about each of these machines. So let me go back to the desktop, and I'm going to issue a command called ipconfig. Once again, remember, we're talking about a Windows machine. So I am on PC2. I'm going to issue ipconfig, and we're going to have a look at what it gives us in terms of a response. So when I look at ipconfig, and if I find the IPv4 section, which is right here, then you realize that the IP address is the same thing as I had mentioned before. It is 192.168.10.2, which is the same IP address that I had configured manually. You'll also see something that talks about IPv6, because there are two versions of IP addressing schemes. We have version 4, which is the traditional one, and we have version 6, which is the new one. But for most intent and purposes, we are going to be focusing on IP version 4. So this takes care of the IP address. But remember, I had also mentioned that there is a number below the machines, which is the MAC address. That is also going to be important. So how do we find the MAC address? Well, going back, we can use a variation of ipconfig. But we are going to use it with a option, and we put the / and we put all, which means I want to run the ipconfig command, but I want to make use of an option that gives me all the information that ipconfig has in store. And if we hit enter, then you will realize that we still have the version 4 information in terms of IP address. But we also have something here that is called a physical address. And if you look at that number, 0060.3EB7E54B, and you map it back to this number that you are seeing here on PC2 or below PC2, you will realize that it is the same number. Now, this number is there because the fast Ethernet interface, and notice right here it says fast Ethernet. That interface or that component physically comes with an address that is burnt into it or built into it. And that address or that number uniquely identifies that particular interface. So therefore, when we have a look at the IP config information, there are two things that are important for us in terms of networking. At this level, we are interested in the physical address or the MAC address. And we are also interested in the IP address, and specifically the version 4 address. So those are the two pieces of information that you are looking for. So that takes care of what we want to cover in this first session of the series. And in the next session in the series, we're going to have a look at some troubleshooting in relationship to the peer-to-peer network that we have created here and see some of the issues that we can have and how to resolve them.